Well, rooms changing always causes trouble, but I hope everyone is here who wants uh, to know something about XS magic. I'll talk about creating XSAccessors. Why do you want to use accessors to get access to hashes and objects and everything else in the first place? For errors checking, since plain hash access won't catch typos and so on, and you can end up writing to different key that you wanted. And for extensibility, you can have accessors in for one classes and functions with the same name in other classes. With plain hash access, you won't have this possibility. Who here has written XS? Oh, that's great. Since I'll show examples of code, and not always it will be the complete code example. Sometimes it's just a part of a function. That's the simplest Perl accessor you can have. And it's a reader and writer, but is it enough? Maybe everything you need is just to create those simple Perl accessors and live well with them. Unfortunately, it is not so. This simple accessor can be executed just only 3 million times per second, and plain hash access is 10 times more. So can we try to improve it? Make it faster without having to write some C code? For sure. This is slightly more obfuscated accessor creator. That's not the Perl code you write every day of a week. And for example, static analysis tools will scream at that. How much speed does this gives us? Not much. Can we improve it more? Well, a bit. You see, can you spot the difference in getter part? Instead of using argument list, I use shift to fetch our argument, and this gives us a little bit more speed for getters. From this point on, I'll talk and show examples more about getters, since you read variables and so on much more common than you write them. So optimizing getters is more important. This gives us about 10% more of the speed, and you can do another thing. The third line there for eval, I do not show the source code for it, but you just, instead of closing over the field variable, you imprint it into the eval string, so it won't be fetched. It will use string literal. But why do those two functions, two accessor functions, differ for 10% in speed for such a small change? To understand that, you need to watch how Perl executes code. To help with that, we have a great model, be concise, and it can show you the guts of the Perl interpreter of code execution. Every line of Perl code is first translated into those opcodes. So This is be concise output for those for small part, for getter part of those accessors. First one with a shift, and second one with a arc array access. And you see that you probably think that, oh, this is a very simple operation, just fetch a 0th element from your arc array. But if you look at it closer, it becomes 4 operations. Simple operations, but there are 4 of them, and it turns out that for Perl, having less opcodes is beneficent. You have one opcode that performs complex tasks, but it is faster than 4 simpler ones. And you might wonder, why do I show this Perl accessors at all? And this slide will help us later. It will show us the way to optimize XSAccessors. So we have our Perl accessor that can be accessed 10 times less than direct hash access, and we want to improve this. Let's go to the next level, to the XS level. XS is a glue between C and Perl. It provides you a lot of macros to manipulate with Perl data, and also you can access Perl internals, not always documented. So let's create our XSAccessor sub. We start very straightforward. We just fetch arguments. We'll need a name where to install our accessor, and the hash key it should access. So we fetch them and install our XS sub. But here's a problem. The installer doesn't take more arguments. All arguments are shown here. And where do we put our key? Luckily, XS subs, since they are not normal Perl subs, there is one free pointer. For normal Perl subs, there is a pointer to their op tree. But for XS sub, there is no op tree. So this pointer is reused, and there are a lot of such things in the Perl core. So we can just grab this pointer and put our key into it. But there is a catch. There are 2 catches actually. Can anyone spot them? Or maybe know them in advance? This code won't work always. Yeah.
Your key is going to leak.
Yeah, that's the first one. There is a second one, more subtle. This code isn't thread safe. If you create a new thread, in the previous one everything this may be destroyed, and you will get core dumps. For example, this was a problem with mouse since its beginning, and this was fixed like only a year ago. This very thing. So we have to find a way to avoid both of those, to avoid a leak and to avoid core dumps. And here magic comes to save us. Do you know about Perl magic? It's real magic. Any variable in Perl, even ones you won't first think of, like subs, can have a magic attached to it. A lot of commonly used Perl variables are already magical, like environmental hash and error variable, and so on. So we can put a magic to our accessor sub to hold a back reference to this key. And in the threaded environment, we will fetch a key using magic. We will have to search a magical array for this sub and retrieve it. But for non-threaded Perls, we can avoid this. We can still directly access our pointer. After casting magic, I turn our magical flag off, since the only thing our magic is for is to hold references. It has no magical callbacks. Since I declare our magical table static outside of the scope of the function, it will be zeroed by default by our C compiler for us, so we don't bother with zeroing it. Here is still a problem with our key. There are always problems with keys. Since it came from the outside, someone can still hold a reference to it, like our caller sub, and it can modify it without even thinking that, oh, I'm modifying a key and it's used somewhere else. So we have to copy it. But instead of doing a simple plain copy, I'll do some more elaborate thing with it. I'll create a shared string from it. What are shared strings? It's all about how Perl hash are accessed. To access any hash, well, not any, but almost all, you have to compute a hash function for a key. Computing hash functions are cheap, but if you compute millions of them in a second, this can imply some penalties. So Perl has a way to avoid these computations for known strings. For example, for strings known at compile time. And furthermore, Perl internal hash uses bucketing. So if you have a same hash for two strings, keys still can be different. But if it is a special key, Perl for sure knows that they're different if the key is different. So by pre-sharing our key, we avoid some comparisons in and hash computation for each key access. So this speeds up things even more. And since we obtained a fresh SV and we own it, we have to decrease the reference counter for it, since casting magic increases that reference counter, and that worked here, since the key is not ours. But here, the key is ours. And now getting to Accessor itself, this was just an installation, and it was already complex. But accessors are simple. They're really simple. You just fetch key from a hash. This is slightly optimized XSub, since you don't see here any XS returns or other macroses you will commonly encounter. Since we know that this is a getter sub and it gets its single argument on the stack, so we just use this stack portion for ourselves. we get quite an improvement. We are now 3 times faster than Perl accessors, but still lagging behind for like 3.5 times from the direct hash access. What can be improved here? Improving installation is pointless. It's executed only once, and this is a really simple access sub. Nothing can be taken off it. But as I showed previously, we can turn to optree, and this is how Perl executes method calls. You have it places arguments on its stack. So what to call, which arguments would it use, and so on. Here are two types of call. Whenever you are calling a static method name and we are calling a dynamic method. For dynamic method, you will see different opcode used. It's method. For static subs, for static methods, it's method named, and they receive their arguments differently. Method names named receive them using opcode itself, and method receives it using the stack. But method and method name just calculate what to call. The real call will be done by enter sub opcode, and it is very complex since it has to cope with all different types of subroutines, Perl ones, XS ones, Perl subs that close over something else, and that can be in all different forms. Like you can call at least 3 things if it's a reference to sub or sub itself, and something else I can't call it. So it's a really complex opcode. Can we simplify it? Yes, since we know what we are calling just a simple xsub that has nothing in it. It doesn't need, for example, scopes. It doesn't need to free anything after it, since it provides no mortals. But at first, how do we install something else instead of the default opcode handler? And how do we mark that we have something of our own installed? Luckily, there is a field. Currently, it's just 1 bit, and I hope Perl porters will never take that bit from us. There is a free bit that we can use in each opcode. It's called opspare. For some time it was even 5 bits in it, but that was like 10 years ago. So let's check if this is a intersub opcode that and it hasn't been stolen by someone else. And if we ourselves haven't already stolen it, let's install our own executor for this opcode. And have you profiled like class XSAccessor subs or any fast accessors using DBIx? Probably you have, but just didn't recognize it. All those calls are shown as being done only 1 time, and this is exactly the reason for that. After we steal opcode executor, it won't execute DBIx anymore. It will show as time spent on this line, but not in this sub. And opcode executor is really simple compared to the core version that spans like 3 or 4 screens, I think 4 screens at least. We just take argument for us from the stack, and if it's what it is really supposed to be, we call directly our sub. How can it be different? Since objects are different, you can have we can end up here calling at first one object with our accessor and then calling a different object with different sub, or even if this is a fixed method name. When method names are not fixed, situation gets even worse. But almost 90 or even more % of the call sites are static. You always end up in the same sub each time you iterate over there. And of course we have a fallback mechanism if for the second time we enter here, if this sub is not suitable, is not ours, we fall back to the default Perl executor, and we won't end up flapping between our opcode and Perl opcode, since we don't clear the opspare bit. Default, since it's pair, it's not used by core or by anything that tries to steal global enter sub, or at least shouldn't. How much speed does this gives us? It's not 50%, I think it's like 30% of an improvement. And this is what class XSAccessor does. But you can go even more. Let's look again at this picture. We've just hooked into sub opcode, but there's also a method opcode on top of it. Can we get something from stealing it? And probably, but how do we steal it in the first place? It's located in this output on top of our opcode, so we first execute method named, and only that, then we execute enter sub opcode. Luckily, Perl op3 is linked in 2 different ways. This is an execution order that's shown by passing an exec option to be concise. But this is a secondary only. This is only a secondary order. At first, op3 is created in a parsing order. If we just omit any options to be concise, we can see that, and only then it's transformed to the execution order. You see, there are some nodes on the right that are absent on the left. They are not executed at all. And on the right, on the very far right, you have marks for the execution order. So in the parsing order, enter sub is on top of the method named, and this information isn't cleared in the runtime, so we can access it anytime we want. So let's find method named from our enter sub opcode. It's a bit more complex, but the end result is the same. You steal another one opcode. What's the problem with it? It's complex. It's almost it's even more complex than the enter sub opcode, and that complexity taken of it. Since it has to deal with a lot of types of calling a method, and if we want to get the most of it, we have to copy this complexity into our own code. And furthermore, it changed between Perl versions. For example, I was able only to create a common method opcode sub only starting from the Perl 5 version 12. Perl 5 version 10 is quite different from it. Do we really get anything from just copying a lot of code from the Perl core to our own sub? Yes, but it's not obvious why do we get any benefit from it. Opcode transition isn't cheap, so we remove 2 opcode transitions, and secondly, accessors are not only hash accessors. You can have class accessors or inherited accessors that are called on packages, and method opcode resolves this package name like string main or string foo into a stash internal object representing everything in that package. And this resolution is also not cheap. It requires at best one hash access to the Perl internally caches those resolutions, since if it encounters a package for first time and you like have 3 parts in it like foo, double semicolon, foo, double semicolon, foo, package resolution is recursive. You have to look up all three parts of it. This is cached, but this information isn't passed between opcodes. So after we resolve it here, our accessor, since it's ours, and we call it not using common opcode structure, we can't modify stack, we can't pass any additional parameters when we are just a common opcode. We can pass this already resolved package into our accessor, and that speed ups not object accessors but class accessors and inherited accessors. We can also pass another one argument directly to our accessor sub. It's a stack pointer itself. I won't show method named codes. It's complex. It differs not much from what you see in core. It just calls our accessor differently, and it gives us another like a third of performance. So now we are only half of what you can achieve doing direct hash access, and that's quite good. But how good is that? We started with 4 million iteration using pure Perl accessors, and ended up doing 18 millions. But doesn't matter at all in your program, since your program has a lot of other logic besides doing accessor access. Have you worked with DBIx class? Then maybe you have profiled it. Have you profiled a code with using DBIx class? No? Well, I'll show you some profiles of it so you will know how it looks like. And DBIx class uses internally class accessor grouped model that gives you an ability to create your own accessor types. And it's slow. It's really slow. For example, for it's a package. I'm talking about inherited accessor types from it, and it's like 1 million of iterations per second for inherited accessor defined in the package. And with inherited accessor you can have values set at one point of inheritance chain and then modified in another point of inheritance chain. Like you have a parent, you define accessor and a value for it there. Then you have it in all of its children, but you can modify it in any of its children, and the modified value will be you can get just from the children. For all other classes it will be the same as set in the parent. And for those inherited accessors, when you are reading the parent itself, it's like 1 million of iterations per second. And for grandchildren it's 5 times less, like 200,000 iterations per second. And it degrades quickly the larger your inheritance chain is. And for DBIx class you have very large inheritance chains. So you have and with XS techniques you can get like 13 millions of accesses per second, so it's 10 times more. Does it matter? This is a profile of some open source application using DBIx class. Its author normally uses DBI, then try to port it to DBIx class. I had to optimize it a bit, and that's not all. It's still not optimal, since you see resolve culminant font, resolve authors at the beginning of the profile. But on the third place you see get inherited from the class accessor grouped module, and at the bottom no, you don't see it here. So this is accessors from DBIx class, and they take like 3% of the time if you count database access. If you remove the database access, it's like 5% of the time spent just helping you. And here's another profile. It's incomplete since it's our internal application. Here are only parts relevant to the DBIx class, and here get inherited is at the first in the first row, and second to last row is get superpaths. It's what class accessor group uses to resolve inheritance. This application performs very simple queries, but that gives you a lot of rows in the result. And this application performs queries that do not return a result or return like one row. And total runtime for this is like 30 seconds. So get inherited consumes 15% of the total runtime of this application, and it's a lot. So using XS module instead of pure Perl can give you up to 15% of performance. And to do so, you have to hack into DBIx class a lot. There will be two pure Perl screens for it. At first, we define our own inherited accessors that are not just returning what you ask them for, but they can perform an additional work. Since here you just see get inherited, but you don't see what's behind it. And DBIx class uses at least 3 different inherited accessor types. The third one is column, and it can't be optimized using this way since it's what your data, how is your data read. Here we hijack inherited raw instance and this stuff, and hijack component class on read. And I hijack component class on read, but you can go even further. If you never unload any classes, you can change it to become from a read callback to a write callback and just load what is asked for, and then you'll get even more since you spend no time doing those checks on every access. And then we have to go into the DBIx internals and just override how accessors are created. Just pass them to an access module, and that will save you like instead of 50 from 5 to 15% of your application run in those Perl accessors. You'll spend just from 0.5 to 1.5% in it. So that's the power of an XSAccessors. This talk will be available at my GitHub account later this day. Do you have any questions? Yeah.
Are the options shared between threads?
Yes, and if, for example, like here, like here, you see string attached to a method name, and whenever thread is cloned, it gets cloned too. But the optree itself is shared.
That means if you're modifying the option directly, like setting the spare bit, that will also affect other threads that may be running at the same time?
Yes, but if we encounter our sub in another thread, it will, and it isn't suitable for the optimization. It just gets left off immediately and resumes its normal execution. I do not modify the optree itself. I do not mangle with any pointers, only opcode properties. And the only thing that can be here you modify optree 2 times, but since you set the spare bit first, anything later that encounters it, it just ignores it if it's a default opcode. And if it's already ours, after the second line, we lift off the optimization if it isn't suitable. Yeah. Yeah, it immediately returns. Here's what's from the inter sub, but in the method you have like peel op next, op next. Yeah. Yeah. Sorry. I'm not creating any new ops. This is the full code. I'm only modifying what's already present. I'm not adding new ops, not allocating any more memory, only modifying. So I don't have to release anything. This I'll show in this form. I'm not modifying pointers from the method named to point to another op. I leave it in place. Only from the code itself I go to that. Right, so if anything else is executing in this place, so it won't be hurt. Yeah.
Next optimization step, custom op.
Not really. Since what you have here is already a custom op, it's completely written inside my module.